I'm just going to say a few words, and then Luke will do some demoing, and then hopefully we have time for some questions afterwards. So over the last, I'd say 5 years in particular, we've just sort of increasingly heard from customers and internal teams how it's really hard to write and in particular maintain large code bases in JavaScript. For a variety of reasons, you know, like, I mean, the language, as you all know, doesn't really have any structuring means beyond functions, so there are no classes, there's no modules. But also, there's no static typing in the language with which we can communicate contracts in teams. You know, like big teams like to actually be able to reason about if I'm supposed to implement this contract, what's in it, what methods, what functions, what interfaces. And also, static typing is one of those sort of things that have powered the IDE revolution over the past decade. If you look at things like code completion, refactorings, go-to-definition, navigation in large code bases, it's all largely powered by static typing. So when we were thinking about where to go next with JavaScript development tools a couple of years ago, we thought it'd be great if we could somehow strengthen JavaScript with these things that are missing, like classes, modules, and some form of typing. But we wanted to do so in a way that did not at all take away any of the inherent advantages of JavaScript, the standards web, cross-platform, and so forth. And so TypeScript is the outcome of that. And sort of marketing speak-wise, TypeScript is a language for application-scale JavaScript development. But technically, it is a superset of JavaScript that compiles to plain JavaScript. And the compiler itself is written in TypeScript, and the code that it generates is just plain JavaScript that runs on any browser, on any host, on any OS. And the compiler and the associated language services are open source. So unlike other languages that target JavaScript, TypeScript starts with JavaScript. And that means that every line of JavaScript out there is also TypeScript. You can copy and paste JavaScript into a TypeScript file and just go from there. And it also means that TypeScript works completely seamlessly with all of the existing JavaScript frameworks that are out there, like Node, jQuery, Express, Backbone, Underscore, et cetera, et cetera. And then the thing that we add in TypeScript is classes, modules, arrow functions, REST parameters, a bunch of things that are actually already proposed in ES6, and we're very aligned with those proposals. And then we also add optional static typing on top, and through that amalgam of things, we can then build great tooling because we now have a foundation upon which we can reason about code and navigate larger code bases. But the good news is that it all compiles away. So when we compile to JavaScript, we basically generate what I would call idiomatic JavaScript, the same kind of JavaScript that you would generate to do prototype inheritance and to do function closures for modules and so forth. And as I said, the final code, there's no shred of evidence left that it came from TypeScript, so to speak, and it runs anywhere that JavaScript runs. So that's sort of the short spiel, if you will. We'll have Luke do some demoing, and then we'll do some Q&A afterwards.
All right. So yeah, I say get to do some fun, the fun part here, and just walk you through what some of this looks like in our tools here. So as Anders mentioned, TypeScript just starts with JavaScript. So we can paste in a piece of JavaScript code. This tool I have here is something that's on our website, the Typescript Playground, which lets you just try out the language, see what it looks like, see what the generated JavaScript looks like, and then run that. So I'm starting here with just some JavaScript code. I have a constructor function, a member on its prototype, create an instance of that, and then play around with the DOM a little bit. A couple of things to notice. One is that I wrote this code on the left. The compiled JavaScript, because this was just JavaScript to begin with, I'm getting back exactly the same thing on the output. There's a little bit of white space removed, but it's exactly the same JavaScript code. I can go ahead and run this. We see our beautiful web application here, which when I run it seems to have a little bug in its hello world output. And so if I come back into here, we can start using the first sort of TypeScript value add piece. And that is to actually add a type annotation. So if I put :string here, that's me indicating my intent. That is the author of this piece of code. I intended this to be called being passed a string. This does a few things. The first thing is it does not change the output at all. So you notice that this just completely disappears in the output. That means that these types won't have any performance overhead. They won't have any change in the semantics of your code. You can still reason about your code exactly in the same way as you would have if you'd just written the JavaScript without the type annotations. That's a really, really key foundation for the way that we think about types. The next thing is we saw that as soon as I typed that, I got this little red squiggle here. And the compiler is telling me, hey, you probably did something wrong here. You said that this thing was supposed to take a string, and you passed it this object literal here. And so here's a place where we start being a little bit, having a little bit of an opinion in a sense on, technically in JavaScript, there's no problem with just passing this object literal to something that maybe if you treat it as a string, that'll work out all right. But probably you don't. And so here we're sort of saying we think that's probably an error in your code. We're going to give you that feedback on the fly as you type your code. So I can fix that just by removing this. The next thing we get is we start to get some of the tooling to light up. So I can come up here and type in greeting dot. You see we get a completion list at this point. We get feedback about, because I know this is a string, because the developer indicated that intent, we can give you a completion list. And this tells me not just the names of the members that are available, so I can see I've got a length property. It also tells me the types of those members. And that's really useful feedback to get directly in the tool, because it means that for members that I don't use that often, like I don't call locale compare all the time. But if I need to, I can look at it right here. I don't need to go read the documentation and look up what I need to pass it, what it's going to give me back. All that information is sort of right there inside my tool. The one thing you sort of may notice here is that when I made that change, I originally was passing. Let me just go back and undo this. I was originally passing an object literal here. And you may have wondered, well, what if I'd actually intended to pass an object literal there? What if this wasn't supposed to be a string, it was supposed to be an object literal? And so we can actually represent that kind of thing in here as well. So we can say that this greeting is actually some object which has a message property that is a string. So if we want to pass around sort of structured data, we can indicate that within the type system here. And you see that as soon as we do that, that's another way of sort of fixing the error that was being reported to us. Now, well, and I should also show, of course, now because I have that, when I hit greeting dot, we see that that thing has a message property. Now, of course, if we were doing this in any real program, these kind of things would get pretty big. If we were passing around packets of data and we wanted to actually type them, typically our objects have more than one member. So here we can go and just give that thing a name by calling it a greeter options, and then putting a message property in there. And interfaces in TypeScript are just a way of giving a name to some structure for an object. And so we can come back in here and just replace this inline thing with greeter options. It's important to notice that this is a just structural contract. This isn't like nominal typing like you'd get in Java or C#. This is just a structural contract that the thing being passed in as this parameter better be an object which has a message property, and that message property better be a string. So that's the intent that I'm indicating. But we can pass any object literal we want in here as long as it has the right things. If, though, we made a typo, we get that error again. And similarly, if we pass the wrong kind of data, again, we see the error comes back. So we're able to sort of flow all that information through. Now, we can add other things to these interfaces. So for instance, let's say that this greeter options also can have a function on it. So we can say that there's a function foo which takes an x of type number and returns a number. Now, when we come back in here, we can see greeting dot gives us back that foo function. And in fact, if I say var x equals greeting dot, you'll start to see we get a little bit of type inference. So because we know that foo takes a number and returns a number, that means we know that x is a number. And so we don't have to add type annotations for these things. A lot of this information is just going to flow through type inference. Now, we can do other interesting things. So properties and functions on our interfaces is one thing, but JavaScript objects can sort of do a few other things other than just have properties. So one thing they can do is they can be callable. They can effectively be function-like. And so imagine that we want to indicate that our greeter options object is callable. And when called, with no parameters, will return an element. So here we can do something like, we can take this greeting, and while it still has a message property and a foo property, it also can be called. And when we call it, we get back an element, and so we get the completion list here for an HTML element. Now, one last thing here. Another thing that JavaScript objects quality they can have is that they can sort of be indexable, that they can be array-like objects. And so here we can say that if I index this on a number, I'm going to get back a date object. And so now if we come in here and grab the 0th element of this and hit dot, we're going to get the completion list for date. And so this kind of thing can look a bit crazy when you do it in a simple example like this, like what kind of object is going to be callable and indexable and giving back elements and dates. But things in the DOM are not that much more sane than this, right? There's a lot of host objects that have some pretty strange APIs. And by trying to model, taking the runtime type system that JavaScript has and exposing that in a static type system that you can use to describe and model your APIs, we can bring a lot of the richness of those APIs and just expose it into tools and documentation and static analysis. OK, so that's a quick look at some of the, let me just actually go back to the basic version of this. So one other thing with types that I should note, we added this one type annotation here, and I showed how that kind of gives you some tooling benefits. It turns out we were actually getting a few tooling benefits kind of already for free in this code, even when we just pasted in the raw JavaScript. And that's because by default, we give you typing for the core browser primitives, so all the DOM APIs, all the ES5 core libraries. And so if I hover over document, we know that thing is a document. And therefore, we know that createElement is a function which takes a string and returns an HTML element. And we know that it has an inner text property. And this is all useful because it means that if I mistyped something here, we're going to get that error as well. So even when I'm just pasting in JavaScript code, we're able to sort of do some checking against your code because we know something about the core libraries that you're using. All right, so that's a quick look at types in TypeScript. So the next thing that we give you is classes. And classes generally are just a useful tool for kind of this structuring of code. There's a lot of good design patterns that the developers are used to for how to think through classes. But classes in TypeScript are actually very simple and lightweight. They're very much aligned with what's being discussed currently in the ECMAScript standards body for ECMAScript 6, the maximum and minimal classes proposal. And it's basically just ultimately a way of hooking up the standard constructor with prototype properties, prototype methods pattern using a single sort of declarative construct instead of smashing it together manually. And so you'll see that this code, if you've seen what the ES6 classes look like, the code here is effectively identical to those. The key thing that's different here is in TypeScript, we let you describe what properties you have and what types those properties have. This is a way of getting that type information back into the tool again. You can see on the right-hand side, we code generate this into a fairly standard pattern here. This is more or less the kind of code that you would likely write if you're going to write this kind of thing out by hand. And so we're really trying to make sure that the code we generate is really simple and clean and has a one-to-one correspondence with the TypeScript code that you write in. Now, classes are actually particularly interesting for a language like TypeScript, which has a sort of static type system that it's offering. Because a class defines not just a constructor object that you can use at runtime, it also defines a type, which is the type of the instances that are created by that constructor function. And that means that down here, when we created that new greeter object, we actually see that we know that that thing has type greeter, which means, for instance, that if we look at the greet function here, we know what type that has. We know that it takes no arguments and returns a string. And we know that this is referring to, you can see the highlighting here, you can see this is referring to the greet function defined up here. And that's something that would traditionally be quite hard to do with JavaScript, to know that there was that association between those pieces of code, because in general, we could have a lot of different things happening that could make that name bound resolve to something in a very different place. But with the static type system, we're actually able to resolve how those connections are made. One of the other nice things that offers is the ability to do some richer kind of IDE services. Oops. So if I come in here and say rename, we can come and say, oops, I keep doing that too much. We can come and say, change this to say hello, and do a sort of rename inline of our code and actually change both the definition site and the use site at once, and obviously the JavaScript that we got generated out on the other side. So we can offer some of these sort of richer IDE services inside this kind of environment. So the last sort of major concept that that TypeScript brings in, and this one's also something that's being worked on in the ES6 group, is the notion of modules. And so modules, in this first example, this is just an internal module, so the ability to just declare a module that I can use within my single file here. And you see I just took my greeter function, I stuck it inside a module. And a couple of things, the outer module here just becomes a simple sort of closure around the code I wrote. I'm exporting this class, which means I'm just going to stick it as a property on the object that I'm exporting here. And we can do some of the standard things that we would do inside any sort of closure programming in JavaScript. So I can, for instance, take that string I'm using in there and just grab it out as sort of a local private piece of state and refer to it like this. And you see, of course, there we're not exporting the data property, but it is being captured in that closure there. So do all those same kinds of programming styles. But again, modules are useful to TypeScript in particular because they provide some structure over the types as well as a structure over the values. And so here we have a greeter type that's defined inside a sayings module. And so when we hover over this object here, we see that its type is sayings.greeter. So this is part of why sort of all three of these features kind of tie in, and together they're what sort of makes a lot of this really nice. Okay, so that's a really quick tour. Actually, one more thing I wanted to show in here. If I just delete this code, if you have a top-level export from a TypeScript file, just like in the ECMAScript 6 proposals, this defines a sort of loadable module, a module which can be loaded by a runtime module loader. And by default, we actually emit code which is compatible with sort of the CommonJS module system. So here we write that onto a global exports object. And so if I have some CommonJS loader, like if I'm in a Node environment, this kind of code is I can just use to write Node modules effectively. We do have a mode on the compiler where you can say that you want to target AMD modules instead, and then we'll code generate code which will be compatible with any AMD compatible loader like require.js. So that's sort of the quick tour of the language features inside the playground. One thing I wanted to show, if I just go over onto our sample site, we have a handful of samples here that show off a few different pieces of what you can do. One of them I'll just show some of the code for is this little battleship simulation thing here. Try to blow up one of these ships. All right, good, we got one. So really simple little app here. But I'll open this up inside Visual Studio here. So one of the things we made available with TypeScript earlier this week when we put it out was a Visual Studio plugin that can really show off kind of this rich tooling experience inside one of the tools that we build at Microsoft. And so this is the code for that. It's got a few classes in here, and the cell class, for instance, has a handful of properties and functions on it. Couple of things that are interesting. I sort of talked a little bit about how some of the DOM APIs are available for you to program against. We have all the type information for that stuff in this environment. And so we have things like this HTML element. And this, if I just right-click and say go to definition, it'll drop us into this file that we provide called lib.d.ts, which is a bunch of declarations of all of the capabilities that are available inside the browser environment. And this, for instance, has the HTML element type and the element type. If I come down here, we'll see things like onClick is a property that HTML elements have. And it has, it's going to be a property which is a function that takes a mouse event and returns, could return an arbitrary thing. If I go to mouse event, you'll see sort of some of the stuff you're probably familiar with, all the kind of properties that you have available to you on an event passed back to a mouse event. So this file is about 8,000 lines of code that was actually generated automatically from some of the IDL descriptions that the standards bodies provide over a lot of the DOM APIs. And that means that we're able to take all that information that's available from the standard specs and actually make that available into the sort of tooling environment here. So you can use that for static analysis. You can use that for getting completion lists and refactorings and all that kind of thing. So this is actually a pretty useful thing. Now, we do that automatically for the DOM, which is one very big library. But of course, we also want that kind of information to be available for some of the libraries that you would be either using or writing or developing with. And so you see in this example, we're actually also using jQuery. And so if I do $open paren, you see we can actually get sort of some hints about what the different overloads of this function are. And so there's basically 7 different patterns for how we can call jQuery. And they each take sort of different combinations of parameters. So we can get that information, again, in the IDE environment. If I do just one of these and hit dot, you'll see that we can get back sort of a list of the members that are available on here. You see things like we have add class, which again is sort of overloaded. There's 2 sort of valid ways to call it. One of the interesting things to note is if I go to definition on this, it's going to drop me into this jQuery.d.ts file. And this is just a file that we've written. We've sort of written this based on the jQuery documentation, and there's a lot of stuff that actually isn't captured really fully in the API documentation, so kind of going and making sure that we have the information correct beyond that. But this is trying to capture all of the typing of this API surface area, and this is sort of a formalization of documentation. And so this is something that, obviously we could do this for a bunch of different libraries, and we're talking to a bunch of the library vendors, including the jQuery folks, about what the best approach is for developing and maintaining these things going forward. But one of the particularly notable things about this is that in my Warship example, I'm using both jQuery and jQuery UI, you can see up here. And jQuery uses a pattern that several libraries use in JavaScript, where they sort of have a plugin model where the plugins can actually sort of expand the capabilities of existing libraries. So for instance, a typical jQuery plugin will actually go and extend the jQuery prototype with some new capabilities, and also potentially extend the dollar object itself. And this kind of sort of dynamic extension of existing objects is one of the things that traditionally static type systems have not been as expressive with. And it's one of the reasons why typically these kinds of things are done in languages like JavaScript, which have a much more dynamic type system. In TypeScript, we really wanted to make sure we were able to capture all these kinds of patterns because they are so commonly used in a lot of JavaScript libraries. And so one of the things we let you do is actually extend interfaces. So for instance, when I have the draggable member here, if I go to definition on that, you'll see it actually drops me into a different file. So I'm not in jQuery.d.ts, I'm in jQuery.ui.d.ts. And what I did here is I just wrote another definition of the interface, and basically what TypeScript's going to do is look for all the definitions of the jQuery interface and just merge them together. And this means that sort of different authors working on different components which might extend one another can work on those things in parallel and don't have to sort of agree on what their shared surface area is. And this actually allows sort of a lot of that flexibility that you get with sort of these kind of plugin models. Okay, so that's a quick look at this sample. So I've showed Visual Studio and I've showed the Typescript Playground. We also make available an NPM package, so I can install TypeScript. And when I install TypeScript using NPM, I get a TSC, the TypeScript compiler. And I can just run that, and you see it's just a standard sort of compiler that I can plug into any tool chains. The Cloud9 guys yesterday showed how they're using this on their server to provide some basic tooling services inside Cloud9 over top of TypeScript. And this, this is basically a compiler you can plug into to any compilation chain. We support both, NPM as an installation mechanism, but of course also if you want to use TypeScript for node development or really any kind of JavaScript development, you can use it there. And so I just want to show a really quick example of a node app here. So let me open up this image board app. And so this image board app is a basic Node Express-based application. The one thing that's kind of maybe a little bit different from what you might expect to see in a standard Node app is that instead of just calling require directly, which is a very dynamic API, we have a sort of a declarative form for import and export. And this is, again, based on the ES6 module import-export syntax. And the key reason this is important is because it allows us to know not just that this express object has been brought into the environment, but also that any types that live within that module, that we can refer to those. So for instance, when I have express here, that refers to the express module. But express.createServer actually returns a express.expressServer type. And so this type was defined inside that module and is something that we can get back inside this environment. Now, this application here, for instance, uses a few other libraries. So if I go into this DB, this is representing my database connection. And you see a few things. One, it uses MongoDB, and we have a sort of a really rudimentary library typing over the Node MongoDB wrapper. But we can also use interfaces, for instance, to describe what our intent is for the shape of data that lives in our MongoDB database. So if we're calling some remote I/O capability, either into a database or across to some web service, we can sort of describe what we expect the shape of that API to be, and we'll get checking against that. And it's no runtime guarantee that our data does have that shape, but it will make sure that as we're writing code, we get the help against that. And so let me just go in here and just show that running for a second. So if I come in here and I look at that file, you see we were looking at app.ts. So I can just run tsc app.ts. It actually goes and finds all those dependent files and compiles them. And then we can just run node on our app and go to localhost 3. Oops, missed a 0. There we go. So we have a simple, app running here against Node. Saw the great category theory talk yesterday. We have books that I like. The working categories for the working mathematician. But basic, just simple app here that we can use against Node. Okay. So that's a quick look at sort of all the main pieces of technology. The last thing I wanted to show is Anders mentioned at the end there. We've put all this out open source. So all the compiler and the core language services that you would need to use to build any tooling on top of this are available here on Codeplex. We use Git, so if you want to clone this, you can do that off of the Codeplex link. And we're doing. Oh, don't have an internet connection. So we're using Codeplex and Git for the open source project. So that's a quick summary of what we're doing with TypeScript, but would definitely love to have any questions that you guys have. So thanks. Yeah.
Thank you.
Hey, got a question over here. Very cool. Is there a way to do module.exports equals?
It's a great question. There is not currently. We would love to do something like that. I think we want to make sure we work on that along with the standards body. In the ES6 proposals, there is not yet a way to do that either. But I think in both places we have to do something about that problem. So yeah.
Over here. So what's the support plan in terms of Microsoft and TypeScript? How, if I wanted to go build something that I would like to last for a long time, what kind of commitment does Microsoft have?
So I'd say right now what we have out is a preview. It's a 0.8 release. We're hoping to be at a 1.0 sometime in the next year, certainly. But we'll see. We're putting it out there, trying to get the feedback now. We'll see where that goes. We certainly have a long-term commitment to trying to make this thing into something useful. We'd love to build great tools around this. We'd love to generally support this. But we'll see. It's going to depend a bit on how much you guys like it, right? How much investment we're able to put into it.
Over here, I got two questions. So when we were working back on Bespin back in the days, Patrick Walton wrote a library that interference types for libraries like jQuery.
Yep.
And there's also Doctor.js with interference types of JavaScript. So do you plan to come up with some kind of tool where you just dump your library and you do some kind of more advanced analysis, and then you create at least some interfaces that the developer don't have to do that yourself? And the other question is, what are you doing if you pass in, so for an argument, if the shape doesn't match? So because you might have one type, or you have one kind of class which has this shape, and for the same argument, a different shape, and then you do an instance object to do different code paths within the functions, if that's possible.
Sure.
I could take the first one. Maybe you could. Well,
Yeah, okay.
Do you want to take the second one first?
Sure, sure. With respect to different shaped classes, so the type system is a structural type system. So it doesn't really matter. You can define the same interface umpteen times as long as they are structurally compatible, have the same members. You can substitute one for the other. Yeah. So
I think maybe I got the question that the way we would normally solve that is with overloading. So I don't know if I explicitly showed it, but you can sort of have overloaded signatures, and so you can say that this function takes any of these 5 shapes, and those shapes can include two different object shapes effectively. Right. And then you would implement that by having an instance object that's split at runtime, or however you would do it in JavaScript today. But typically, that can be the intent can be described by a set of overloads, and that's how we do it. We don't have a union type, for instance. I think on the other question, in getting the types automatically out of existing JavaScript, we know that that's sort of the whole point of this is effectively that that's not possible to do 100% correctly, because if we could just get all the types out of plain JavaScript, we wouldn't need to do all this type annotation stuff. But we do think there's a lot we could do to try to get you 50, 60, 70, I don't know exactly how far it is, but % of the way along that process, using some automated tools, kind of like the things you mentioned. And I think that's an area we're definitely going to be looking into as we try to help people to create these library typing assets.
Cool. All right, we're out of time, unfortunately, but you know where to find these guys. So thank you guys for coming.
all right,
Yeah,
thanks.
Thank you.